So we will take some more problems on finding the maximum and minimum value of a function in the case of an unconstrained optimization. So the problem runs like this. We can take the problem. A firm has a total revenue function. A firm has a total revenue function. Income. Revenue is income. So income is given by R is equal to 20x minus 2x square. Total cost function. Total cost function, that is expenditure. Revenue is income. Cost is expenditure. C is equal to x square minus 4x plus 20. Two functions are given where x represents the quantity. Where x represents the quantity. Find the revenue maximizing output level. Find the revenue maximizing. So revenue should be maximum. Maximizing output level. And the corresponding value of profit, price and total revenue. Profit, price and total revenue. This is the problem. So it is an unconstrained optimization problem because there are no constraints given. So two functions are given here. One is the revenue function, another is the cost function. So let us take the revenue function. R is equal to 20x minus 2x square. Cost function is x square minus 4x plus 20, where x is the quantity. So quantity of product, we can say. So let us say that that may be a machine or it may be a mobile, something like that. So x is the number of quantities of that particular object. So this is the revenue, this is the cost. So if you subtract the cost from the revenue, you are going to get the income. So profit function, the profit function I will call P. So P is the profit function. So profit is given by revenue minus expenditure. Revenue minus cost. Correct? So revenue is whatever you have earned, whatever you have got, selling price you can say. Selling price minus cost price is your profit. Okay? So if the selling price is more than the cost price, then it is profit. If selling price is less than the cost price, then it is loss. That's what. So now what is the function now? So P is equal to R minus C means here R is given as 20x minus 2x square. Minus C means x square minus 4x plus 20. This is your profit function. This you have to derive. So you say it is x square minus 2x square minus x square is minus 3x square. 20x plus 4x, 24x. Then minus, correct? This is the profit function. 20 minus 2x square minus of x square. Yeah. Now what we have to do here is, since this is the function we got, let us see, before that we will see whether this revenue, whatever we have got here, that revenue function, if you differentiate with respect to x and equate it to 0, what happens, let us say. So consider dr by dx. That is d by dx of 0. So if we equate it to 0, that is the first condition. First derivative should be 0. What happens? 20 minus 4x is equal to 0 or x is equal to 5. That means we can produce 5 products. Suppose at x is equal to 5, what is the second derivative? D square or by dx square. Once again you differentiate this, that is d by dx of 20 minus 4x, which is minus 4. Correct? Derivative of 20 is 0. Minus 4 means it is less than 0. Less than 0 means maximum point. Correct? Maximum point is second derivative is less than 0, it is the maximum point. So d square or r by dx square, so revenue will be maximum at x is equal to 5. What does it mean? Revenue is maximum. We are worried about maximum value only when x is equal to 5. So if you produce 5 quantities of that product, you will get maximum revenue. That is the meaning. Okay. Now let us see what is the value of this P when x is equal to 5. So when x is equal to 5, what is the profit? Profit P is equal to, we have got profit P as minus 3x square plus 24x minus 20. Substitute x is equal to 5 minus 3 into 5 square plus 24 into 5 minus 20. So what is the answer? This is minus 75 plus 120 minus 20. I think it is 25. Correct? 25 is the product. It is some unit, 25 lakhs, some rupees, something like that. Okay. So this is the profit we have got. Now, some corresponding value of profit we got now. Next, what is the price of the product? Price we have to find. Price of each product. Price of each product is given by capital P divided by x. So 25 is the total profit. This actually is total profit. Please note that. Total profit is nothing but your total revenue minus total cost. So if we divide this is total, how many we have produced? 5. So for each cost, price of each product we have 25 by 5. That is 5 units is the answer. Okay. So maximum revenue is how much then? Maximum revenue. Maximum revenue is equal to at x is equal to 5. So what is the revenue function he has given? 20x minus 2x square. 2x square. Wow. 20x minus 2x square. So 20 into 5, put x is equal to 5. Minus 2 into 5 square. So 100 minus 50. This is the maximum revenue we got. So these are the total revenue, that is maximum revenue. Maximum is total. This is a very simple problem. So it's a practical problem. There are no constraints given in this problem. That is why it is called as unconstrained optimization. So one more problem will take. Second problem. The total profit Y in rupees. The total profit Y in rupees of a drug company from the manufacturing and sale of X bottles. From the manufacturing and sale of X bottles X is a number. X bottles is given by, is given in the form of a function. Y is equal to, the f of x is a function minus x square by 400 non-linear function plus 2x minus 80. You can see x square term is there, therefore it is a non-linear function. So first question, how many drug bottles must the company sell in order to achieve maximum benefit? Sell in order to achieve maximum profit. So profit is y. That means we have to find out y max at what x. Okay, x we have to find out at what value of x we have the maximum profit. Next, the second one, what is the profit per drug bottle? What is the profit per drug bottle when this maximum is achieved? That means here y max we have to find out. Here we have to find out x. Here we have to find out y max. Okay, simple problem. So here he has given the function y is equal to this much. So we have to use both the conditions, necessary condition and sufficient condition. So he has given y is equal to minus x square by 400. Y is the profit, x is the number of bottles. Here he has directly given profit function. In the last problem he has given revenue and cost. We have to take the difference. Here he has given directly. So this is given. So first condition we have to use dy by dx is equal to 0. So what happens? Minus 1 by 400 into 2x plus 2 is equal to 0. 80 does not have any derivative. So if you simplify this, what is the value of x you are going to get? Minus x by 200 plus 2 is equal to 0, or x by 200 is equal to 2, x is equal to 1. So number of bottles 400. Now we have to check whether we get the maximum or minimum. For that we have to take the second derivative. D square by dx square is d by dx of this minus x by 200 plus 2. Here it is. What is the derivative? Minus 1 by 200, which is less than 0. Negative. Negative means it is maximum. So we get the maximum profit when you manufacture 400 bottles. So therefore, what is the first problem is over. First step is over. 400 bottles manufacture. So maximum profit becomes that we have to put x is equal to 400 in this function minus x square by 400 plus 3x minus 8. So minus 400 square by 400 plus 2 into 400 minus 8 minus 400 plus 800 400 is 1. Correct? Rupees 300. That is the profit. Correct or not? So x we have to find out in the first step. Then we have to find out the value of y in the second step for that value of x. Only thing is we have to check here whether we get maximum or minimum. For that we have to get the second derivative. Second derivative, if it is negative, it is maximum value. So this is how we can find out maximum and minimum values of a non-linear function when constraints are not given. Unconstrained. ಇಲ್ಲಿ ಆ ಕಂಡೀಷನ್ ಏನಿರೋಲ್ಲ ಆಯ್ತಾ ಒಂದೇ ಒಂದು ಇರ್ತದೆ ಎಕ್ಸ್ ಮಾತ್ರ ಇರ್ತದೆ ಇಟ್ ಇಸ್ ನಾಟ್ ಟೂ ಡೈಮೆನ್ಷನಲ್ ಇಟ್ ಈಸ್ ಓನ್ಲಿ ಒನ್ ವೇರಿಯೇಬಲ್ ವಿಲ್ ಬಿ ದೇರ್ y is equal to f of x ಮಾತ್ರ ಸೊ y is equal ಎರಡು ಬರಲ್ಲ z is equal to ಆ ಲೀನಿಯರ್ ಪ್ರೋಗ್ರಾಮ್ ಇರ್ತಲ್ಲ ಅಲ್ಲಿ ಎಕ್ಸ್ ವೈ ಎಕ್ಸ್ ಒನ್ ಎಕ್ಸ್ ಟು ತೊಗೊಳ್ತಾ ಇದ್ವಿ ಇಲ್ಲಿ ಆ ಥರ ಬರಲ್ಲ ಸೊ ಓನ್ಲಿ y is a function of x only. This is called as one dimensional optimization problem. One dimensional x ಮಾತ್ರ ಇರುತ್ತೆ y is equal to RHS x ಮಾತ್ರ ಇರುತ್ತೆ. So first condition, necessary condition, first derivative is 0, get the value of x. Then second derivative, if it is negative, maximum, positive, minimum value ಬರುತ್ತೆ. Is equal to 0 ಆದರೆ inflection point ಇರುತ್ತೆ. So next maximum value ಬೇಕು ಅಂತಂದ್ರೆ whatever value of x, maximum or minimum, whatever value of x you have got there, that value of x you have to substitute in the given function. It gives.